Hi everyone, welcome to another session of the HBL files. In today's session, we will be talking about simple and other forms of inverse proportion. Let's begin. Here we have a table for the speed of a car expressed in kilometers per hour, as well as the time taken in terms of hours in order to travel a 120-kilometer distance. Let's answer the given questions. For the first one, if the speed of the car increases, will the time taken increase or decrease? As we can see from the table, as the speed increases, the time taken decreases. Next, if the speed of the car is doubled, how will the time taken change? Let us use the given hint. So we have 20 kilometers per hour. We double that to 40 kilometers per hour. Notice that the time taken will reduce by half. Next, if the speed of the car is tripled, what will happen to the time taken? Let's compare when the speed is initially 10 kilometers per hour and when the second speed is 30 kilometers per hour. When the speed is tripled, the time taken will be reduced by 1/3. Next, if the speed of the car is halved, how will the time taken change? Let's use the hint. We'll begin with 60 kilometers per hour and then reduce that to 30 kilometers per hour. The speed was halved, but looking at the time taken was doubled. And for the last one, if the speed of the car is reduced to 1/3 of its original speed, what will happen to the time taken? Let's look at these values for the speed: 120 kilometers per hour and 40 kilometers per hour. The speed was reduced by 1/3, or the speed was reduced to 1/3 of its original value. But looking at the time taken was actually tripled. Now, let's use these information in looking at further examples. We still have this table, but this time let's label the values for the speed and time to be x sub 1, y sub 1, x sub 2, y sub 2, and so on. Now, let's look at the ratio of two speeds in this given table. Say, for example, x sub 1 over x sub 2. This gives us a ratio of 1/2. Now, let's look at the corresponding time taken for these speeds. If we get the ratio of y sub 2 over y sub 1, we'll get the same value, 1/2. Let's look at another set of values for speed. Here, I divided the value for x sub 5 by x sub 2. So we have 60 over 20. We can get a value of 3 out of it. Now, comparing the corresponding values for the time taken, we have y sub 2 over y sub 5. Again, I'll be getting the same value of 3. Based from these observations that we have, we can actually infer that if you get the ratio of speeds 1 and 2, it will actually be equal to the ratio of the time taken y sub 2 over y sub 1. Let's continue solving this equation. Doing cross multiplication, we will have x sub 1, y sub 1 is equal to x sub 2, y sub 2. Now, what does that mean? That means that the product of x and y is actually constant, meaning we can write it like this. k, which is a constant, is equal to xy. Rearranging this equation, we will have y is equal to k over x. Or simply, y is inversely proportional to x. This gives us the general equation for an inverse proportion. Let's use this equation to solve some problems. In this problem, we have if y is inversely proportional to x and y is equal to 5 when x is equal to 2, find the value of y when x is equal to 8, an equation connecting x and y, and the value of x when y is equal to 10. Let's start solving the first question. Notice that in the question itself, we were given initial values for x and y. We can assume this to be x sub 1 and this to be y sub 1. On the first question, we have the second value of x, which is x sub 2. And then the value of y will be our y sub 2, the value that we were asked to solve. That means we can actually use this formula that we obtained in the previous activity. Substituting the corresponding values for x sub 1 and y sub 1, we'll now have 2 times 5 is equal to 8 times y sub 2. 2 times 5 is 10, and dividing each side of the equation by 8, we will get y sub 2 is equal to 10 over 8, or simply 5 over 4. Now, let's look at the values, the initial and final values of x and for y. Now, the initial value of x is 2. The second value of x is 8. There was an increase in the value of x. For y, the initial value was 5. The second value was 5 over 4. And there was a decrease in the value of y. So it's consistent with the idea of inverse proportion. As x increases, y value decreases. Let's go to the second question. An equation connecting x and y. For this one, we will begin with the general equation. Y is, so we have the equal sign, inversely proportional, so we have k over, and then the variable x. So y is equal to k over x. Then, let's rearrange this to isolate k. Now, we were given with the initial values of x and y. We can then substitute that here to find the value of k. K is equal to 5 times 2, and that is equal to 10. Substituting this value of for k in the general equation, we'll now have y is equal to 10 over x. So for this condition, the inverse proportion equation will be y is equal to 10 over x. For the last question, the value of x when y is equal to 10, we will be using this equation that we obtained in the second question. But since we are asked for the value of x, we then isolate x, giving us this equation. X is equal to 10 over y. Then substitute the given value of y, which gives us x is equal to 1. Let's look again at the values of x and the values of y. The initial value of y is 5. The second value will be 10. There was an increase in the value of y. So we should expect the value of x to decrease. And that's what we have seen here. The initial value of x is 2. The final value or second value is 1. The y value increased by twice, or the y value was doubled, so the x value was halved. And again, that's consistent with the idea of inverse proportion. Let's have another example. In this table, we are given with information that y is inversely proportional to x. and we were asked to complete the table. So to begin with, we must first find the value of k. How do we do that? By looking at these values. We start with the general equation, y is equal to k over x, and then isolate k. Solving for k, we now have k is equal to 2 times 2, and that's equal to 4. Substituting 4 to the k in the general equation, we now have y is equal to 4 over x. This equation allows us to solve for the value of x and y in the table. For the first one, we were given with the value of x to be 0.5, so that means 4 divided by 0.5, that gives us 8. Next, to solve for x, we then isolate x, giving us an equation of 4 over y. X is equal to 4 over y. Let us substitute the given value of y. That becomes 4 divided by 4, giving us an x value of 1. Next, the y value when x is equal to 3 will become 4 over 3. And then finally, the x value when y value is 0.8, we will have 4 divided by 0.8. That gives us 5. Okay, so those are some simple examples of inverse proportion. Now let's go to the other forms of inverse proportion. Here we have y is inversely proportional to square root of x. Similarly, we were given with the initial values of x and y, and we were asked to solve for y, given that the x value is 16. We were also asked to solve or to find the equation that connects x and y, as well as the value of x when y is equal to 4. To solve the first question, we will again apply the same concept. K is constant. Let's write the general equation for this problem. It says that y is, so you have equal sign, inversely proportional, we have k over, and then this variable, square root of x. Next, isolate k, we will have y, or k is equal to y times the square root of x. Again, this is constant. So for the product of the first set of x and y values, or the product of y times the square root of x, that will be equal to the product of a second value of y times the square root of the second value of x. Or simply, it's going to be like this. Substituting the given values to the corresponding variables, we now have y sub 1 to be 6, x sub 1 will be 4, y sub 2 is unknown, and x sub 1 is 16. We'll now have 6 times 2, because 2 is the square root of 4, that and equals y sub 2 times 4. 6 times 2 is 12, and then dividing each side of the equation by 4, we'll get y sub 2 to be equal to 3. Again, let's look at the given values. Initial value of x is 4, final value of x is 16. There was an increase in the value of x. For the y value, initial value of y is 6, final value is 3. There was a decrease in the y value. Next, to find the equation connecting x and y, we simply have to find the k value. Again, we'll use this general equation for this scenario, isolating k, and then substituting the corresponding values of y and x. We'll use these values initially given in the problem. We'll now have 6 times the square root of 4. Square root of 4 is equal to 2. Multiply that to 6. we have 12. Substituting 12 to k, we now have y is equal to 12 over the square root of x. And this is the equation that connects x and y in this scenario. Finally, for the third question, find the value of x when y is equal to 4. We will now use the equation we obtained in the second question. Since x is what we were asked to solve, we then substitute the value of y, giving us 4 is equal to 12 over square root of x. Isolating square root of x, we now have 12 over 4 on the right side of the equation. This gives us square root of x is equal to 3. And squaring each side of the equation, this gives us x is equal to 9. So when the y value when the y value is 4, x is equal to 9. Let's have another example. The force of repulsion F newtons. Newtons is represented with the capital letter N. Between two particles is inversely proportional to the square of the distance d. This small m here represents meters. So F, its unit is newtons, and then d, the unit is meters. We were asked to write down a formula connecting F and D, as well as to determine the force given these certain conditions. Let's begin with the first question. The question says F is inversely proportional, so F equals K over D squared. Again, F is inversely proportional to square of distance, D squared. This is the equation that relates F and D in this scenario. Next. To solve the second question, we must remind ourselves that K is constant, which means if the equation is F is equal to K over D squared, rearranging that equation, it will give us F times D squared for K, which means that the product of the initial value of F times the square of the initial value of D should be equal to the product of the second value of F times the square of the second value of D. It was given in the problem that when the force is, the force is 20 newtons at a certain distance. We do not know this certain distance. That means let's just leave it as D1, then substitute 20 newtons for F sub 1. We now have this equation. It was also mentioned in the problem that the distance was halved, and we were asked to find the force when this happened. Now, what does this mean? The distance becoming half is basically telling us that d sub 2 is equal to d1 over 2, meaning the new distance will be equal to half of the original distance. We can then substitute this for d2 in this equation. We now have 20 d1 squared is equal to f sub 2 times the square of d1 over 2. Applying the laws of exponents, we now have d1 squared over 4. Doing cross multiplication, this 4 gets multiplied to 20, giving us 80 d1 squared is equal to f2 d1 squared. Since each side of the equation contains this factor, we can divide each side by d1 squared, giving us the value of the force to be 80 newtons. That means when the distance is halved, the new value of the force will be 80 newtons. So that's it. That's how we solve some simple and other forms of inverse proportions. I hope everything's clear, guys. And thank you for learning with me today. See you on the next session of the HBL files.